Next, large sample type 1, that is single min test, based on size of the sample is known, right? Small n is known and population size, that is capital N, is unknown. A sample of 900 members has a mean of 3.4 centimeters and ST 2.61 centimeters. Is the sample from a large population of means 3.25 centimeter and standard deviations 2.61 centimeter. If the population is normal and its mean is unknown, find 95%, 99% and 98% confidence limit of true mean. So we'll see. So given sample size, so sample of 900 members, so small n is equal to 900. Sample mean also given as mean 3.4 centimeter, x bar is equal to 3.4, and population mean they have given, that is equal to mu, that is equal to 3.25, and sample standard deviation, that is s, small s, that is equal to 2.61. So defining the hypothesis, null hypothesis H naught, mu is equal to mu naught. So it is from the original one. So this mean is equal to the population mean is standard, that is true. Alternate hypothesis, mu not equal to mu naught. So mu not equal to mu naught means two-tailed, right? So let the level of significance, the LOS, be 5%. Test statistics, Z is equal to x bar minus mu by S by root n, because they have given S, sample standard deviation. So we are changing the formula, which is equal to 3.4 minus 3.25 by 2.61 by root of 900. So you will get 1.7241. So calculated value of Z is equal to 1.7241. So tabulated value of Z at 5% level of significance, 1.96. So calculated value is 1.7241, not 1.2308, 1.7241, which is less than 1.96. That is also correct. So the null hypothesis H naught is accepted. Yes, it is a sample from the large population of mean 3.25 centimeter and standard deviation 2.61 centimeter. Next, we are going to find the confidence limit. They have asked to find the 95%, 99% and 98% confidence limit, right? So first, 95% confidence limit formula, x bar plus or minus, for 95% 1.96 Z value, S by root n. Substituting the values 3.4 plus or minus 1.96, 2.61 by root of 900. So you will get 3.4 plus or minus 0.1705. So 3.4 plus 0.1705, 3.5705 upper limit. 3.4 minus 0.1705, that is the lower limit, 3.2295. So the interval is 3.2295. Lower limit, upper limit is 3.5705. Next, 99% confidence limit. So x bar plus or minus Z value 99%, 2.58 from the table, small s by root n. Substituting these values 3.4 plus or minus 2.58, 2.61 by root of 900. So you will get 3.4 plus or minus 0.2245. First lower limit, take the minus value, 3.4 minus 0.2245, that is 3.1755. Now take the plus value, 3.4 plus 0.2245, that is equal to 3.6245. That is the interval limit, right? Next, 98% confidence limit. In this case, Z value is 2.33. So formula is x bar plus or minus 2.33 S by root n. Substituting the values, which is equal to 3.4 plus or minus 2.33 into 2.61 by root 900. So the value is 3.4 plus or minus 0.20271. So lower limit, take the minus value, 3.4 minus 0.20271, 3.1973, comma. Now take the plus value, 3.4 plus 0.20271, 3.60271. Next problem. The manufacturer of television tubes knows from past experience that the average life of a tube is 2000 hours with standard deviation of 200 hours. A sample of 100 tubes has an average life of 1950 hours. Test at the 0.05 level of significance if the sample came from the normal population of mean 2000 hours. So population mean also the same 2000 hours. We need to check that one, right? So given sample size, so sample of 100 tubes, right? Small n is equal to 100. Then mean sample of 100 tubes has an average life 1950. So sample mean x bar is equal to 1950. Population mean, so experience, from the experience they are having mu is equal to 2000 hours and standard deviation, population standard deviation sigma is equal to 200. Define null hypothesis. So there is no significant difference, that is same like the population mean. So mu is equal to mu naught, that is equal to 2000, and alternate hypothesis mu not equal to mu naught. So we are taking not equal, so two-tailed test. Significant levels they have given 0.05, that is 5% level, right? That is already given. So test statistics z is equal to x bar minus mu by, here sigma is given, that is why sigma by root n. Substitute all the values and simplify, you will get minus 2.5. So calculated value of z is nothing but modulus z. You have to take modulus value, so that is equal to 2.5. Tabulated value at 5% level, z value is 1.96. So conclusion, calculated value is greater than 2.5 is greater than 1.96. So null hypothesis H naught is rejected. So the sample is not from the normal population of mean 2000 hours, right? Thanks.